So it says special right triangles notes. Two types of special right triangles, 45, 45, 90 triangle. And then on the back we have the 30, 60, 90. We're going to talk about the 45, 45, 90 first. Before we get into it, these are called special right triangles because they are right triangles. They got right angles in them. So we already know that kind of classification. We've already classified it by its angle. It's a right triangle. You can also classify triangles by their sides. This 45, 45, 90 triangle, by its sides, how would you classify it? Somebody say something smart, not something silly. It's a right triangle. What else is it? Oh boy. So we're going to go with the second answer now? I agree. It's isosceles. You scared me with the equilateral stuff first. This is an isosceles triangle. Y'all should all see that. Y'all should all know what isosceles means still. Isosceles meaning two of the sides are the same. Y'all should be able to see what two sides are the same. Side right here, and this side right here. In our isosceles triangle, and specifically in the 45, 45, 90 triangle, we consider these two sides to be our legs. These two legs are the same. They have the same value. I'm not going to go green or blue. Let's go green. I'm going to highlight these two legs for you. Here and here. If you have highlighters or color pencils, you might want to do this too. I'm color coding for y'all. These are my legs. They are congruent. Y'all should know that. These two legs, whatever one is, I should automatically know what the other is. These two legs have a relationship with the hypotenuse, which is here. These two legs have a relationship with my hypotenuse, which is here. And I'm going to write the two relationships down for you. So say if I was looking for one of my legs. I didn't know what they were. I didn't have my leg, but they gave me my hypotenuse. My leg would equal my hypotenuse divided by square root of 2. If I didn't know what my leg was, but I had the hypotenuse of the triangle, I would do my hypotenuse divided by square root 2, and that would tell me what my leg is. And vice versa. If I had my hypotenuse, oh, wrong color. Oh, excuse me, if I was looking for my hypotenuse. If I was looking for my hypotenuse and I had one of the legs, I would do whatever that leg they give me times square root of 2 to get my hypotenuse. Now, I'm going to show you why real quick. I didn't do this the other class until the other day, but I want to do it real quick for y'all. Show you why this always works out. I'm going to do it in some open area over here. Actually, I'm going to do it on another sheet of paper. Because you don't necessarily need to write this down, you just need to see it. Show you why this relationship works. So I'm going to do two right triangles. Do one here. We're going to call these 45, 45, 90s to 45, 45, 90s. If that's the case, say I said the length of this leg was 5, this leg right here was 5. And then I can do another one too for you. Just want to do one more out here. 45, 45. Say I said the length of this leg was 7 and this one was 7. The relationship is going to remain the same between the legs and the hypotenuse no matter what these lengths are. Let me show you. So on this first one, if I want to do Pythagorean to solve, I could. 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. And then 50 equals c squared, square root. And then at that point, you would get a decimal if you put this in the calculator. Can't give me decimal form though. You have to break this down. Breaking it back down, I know that 25 times 2 would give me 50. And then 5 times 5 would give me 25. Double 5's there. We're bringing that out. I get 5 square root 2 as the length of C. So my hypotenuse would be 5 square root 2. Even if I did this one over here, 7 squared plus 7 squared equals c squared. 49 plus 49 equals c squared. What's that, 98? Equals c squared, square root. Once again, you would get another decimal. Can't give me a decimal, so you have to break it down again. 49 times 2 equals c. Oh, I don't know. I ain't need to bring down the c. My bad, y'all. 7 times 7. Bring the 7's out. You'll get 7 square root 2 equals c. So up here, for my hypotenuse, I get 7 square root 2. It don't matter what two numbers I give you in leg. As long as those numbers are the same, I'm just trying to show you that you're going to keep getting that same thing for your hypotenuse. Whatever your leg is, times square root 2. This is why we know this relationship, so we don't have to do all this work to figure that out. That's why these are called special right triangles. So if you identify a 45, 45, 90 triangle like this, that relationship is always going to be that, no matter what numbers we give you. So if that's the case, we can just use these rules to figure out the missing sides are. We don't have to go through the whole process of doing Pythagorean theorem and all that. We can just quickly identify what the lengths are going to be. Y'all follow what I'm saying? I just wanted to show you how it works real quick. Alright. So down here, that's exactly what's going to happen. It says find the value of each missing variable. So in number 1, first thing you want to do, honestly, this is practice for the 45, 45, 90s, so it should be obvious to you that these are 45, 45, 90 triangles. But when y'all get to the worksheet, it's going to be mixed, so the first thing you want to make sure is you understand which triangle you're looking at. You should understand first this is a 45, 45, 90 triangle. Then from there, identify what you need and what they gave you. On this triangle, I have my two legs here and here. I'm missing one of my legs and I'm missing my hypotenuse. Reese, what's the value of x? Value of x is 8. And then Reese, my hypotenuse is y. What is my hypotenuse going to be? Go ahead, Jackson. 8 square root of 2. Thank you, sir. The work for that, if you needed to see it, I'm looking for my hypotenuse, so it's my leg times square root of 2. I'm going to take my leg here, 8, times it by square root 2, which is going to give me 8 square root 2. I showed you why that works out, but this is just a quick way to do it. You don't have to do no real work for this. And even if we wanted to go in reverse, like I was telling the kids in the other class, say if they gave me the hypotenuse is 8 square root 2, and they wanted me to find one of my legs. If I was going in reverse and I needed to find x and I didn't know that x was 8, I was coming back this way, I would divide by square root of 2. But if you divide, and I'll just put it under here, well, I'll do it over here. If I do 8 square root of 2 divided by square root of 2, those are going to just cancel out and just leave me with 8. That's how you get back there if you was going in reverse. Y'all okay with that? That's just a simple one, man. It's going to get hard. Next one ain't that bad. Number 2. That's a 45, 45, 90 triangle. Chris, what's the value of y? 25. The value of x? X is your hypotenuse, bro. We ain't got that kind of time, Chris. Armando. 25 square root 2. So hopefully most of the ones y'all experience will be easy like that, where you just bouncing back and forth between those two with simple numbers. But sometimes we complicate things for you. It won't be as clean as that. For example, number 3 look like it's straightforward, but if you really examine it, it's not really. On this one, they gave me 19 as my hypotenuse, and then they asked me for X and Y. X and Y are my legs. So once I find one, I automatically know what the other is. So it's not, you don't have to do double work. So 45, 45, 90. One, they gave me the hypotenuse. How do I find the leg on here? Stuff up top, bro. Leg equals what? What you mean you know? You didn't write notes just now? Leg equals what? How hard was that for you to say? So if I'm trying to find this leg right here, it tells me to divide this hypotenuse by square root of 2. Only problem is, and you need to say some space down here. When I write this up, it's going to look like this. 19 divided by square root 2. I don't know if they taught y'all this in algebra, but you cannot leave a fraction in this form. You cannot have a fraction with a radical sign on the bottom of it. If you do, your answer will always be wrong. You can't leave it this way. You have to do what we call rationalizing. You got to simplify this. You got to make it look better than this. This ain't good. To do that, and the best way I can explain it to the kids and make you understand it, I did it yesterday for the other kids. To get this radical sign off the bottom of our fraction, we're going to do what's called rationalization. But you essentially, all you're doing is multiplying the fraction by 1. But the one that you're going to multiply by is going to look similar to the square root of 2 on the bottom, so you can help move it off the bottom. So let me show you something first to help you understand the concept a little better. I'm coming back to 1 because I ain't done with him yet. 1, what's 3 divided by 3? 1, what's 10 divided by 10? So you agree that 3 over 3 is 1, right? And then 10 over 10 is 1? Alright. What's square root of 2 divided by square root of 2? Just 1. If that's the case, this is the one what I want my 1 to look like. Square root of 2 over square root of 2. This is going to help me get the square root of 2 off the bottom of my fraction. So down here I got 19 divided by square root of 2. That's what the x is, but I can't leave it in this form, so I'm timesing by 1. In this case, my 1 is going to look like square root of 2 over square root of 2. I'm doing that because I'm trying to get this off the bottom. By getting it off the bottom, I'm going to basically get it where I can square it at the bottom. So when you multiplying, you understand you multiply straight across. On top is 19 times square root 2, which will give me 19 square root 2 on top. On the bottom, it's square root of 2 times square root of 2, which would be square root of 4. And now I have square root of 4 on the bottom. On the bottom, I can take the square root of 4. What is the square root of 4? 2. So now I get 19 square root of 2 over 2. Now, on this one, And then the last thing I look at is the numbers on the outside. Now that I got a whole number outside on top and a whole number at the bottom, make sure I can't simplify that 8 even more, which I can't on this one. It's 19 over 2, so I can't do it. But if that was 18 over 2, I would do 18 divided by 2 and take that next step, and I would just make it 9 square root 2. But in this case, this is as simplified as it's going to get, so I'm going to leave it like that. Alright. But that would be my value of x. So 19 square root 2 over 2. That means y is that same thing. 19 square root of 2 over 2. So that would be what my legs, the length of my legs are on this one. And if you don't believe me, there are ways to check. But like I told the kids in the other class, especially on this unit, not to walk around. I used to have these calculators at my old school. They don't have them here though. I'm glad they don't have them because y'all be cheating y'all behinds off. If you have one of these Casios, I can't let you use it on the test. I'm not going to tell you how to set it in the right mode, but these Casios do the work for you as far as simplifying radicals. I just want to show you that it is right what we did. So we do 19, 19 divided by square root of 2. It's going to show you the simplified radical. You even do the other ones we've been doing. Like those other simplified radicals, like do square root of 75. It'll show you a simplified radical. That's why I won't let y'all use this calculator. This calculator is a cheat. All calculators won't do this. I'm trying to tell you it don't, bro. The Texas Instruments don't. I know it for a fact. You've not been around for a while, right? You've not been around for a while, right? This calculator that you borrowed from me, it don't do it. If that's a Texas Instrument, it ain't gonna do it either. Unless it's a graphing one. The graphing one's good. It don't matter anyway. You're gonna use my calculator on the test. You're gonna use this one right here, bud. Alright. Last thing. And this is what I told y'all too. I promised you this before break. That this 9 weeks, this last 9 weeks, well, not last 9 weeks, this next one, third quarter, there's going to be a lot of word problem. It's going to be word problem heavy. It's a lot of real world scenario problems we throw at you in this quarter. This will probably be the most relatable to you. It'll probably be the most frustrating for a lot of y'all too, because a lot of y'all bad at word problems. But you'll start to see where the geometry actually connects to the real world in this unit, or in this 9 weeks. Number 4, word problem. Grain elevators are conveyor belts used throughout the Midwest to take produce like wheat to the top of a silo for storage. If the angle formed by the ground and the top of the silo is 45 degrees, how long would the belt of a grain elevator need to be if the bottom is 50 feet from the base of the silo that is 50 feet high? That's a lot of reading for y'all. Y'all probably don't even know what to draw, which is a shame. Let me start y'all. Let's just help you understand what a silo is. Everybody know what a silo is? No. See, there you go. Let me help you out. A lot of y'all seen this movie, so I can relate to you with this. Y'all seen that movie Quiet Place?
Oh yeah.
A lot of y'all ain't seen that? Yeah, you remember the kids fell in that thing? That's a silo. Yeah. They wasn't in the water, no. When they was in that grain, bro.
Oh, they was in the grain?
Yeah. Yeah, it's a silo. But, that's what they're saying. They're saying a belt takes the grain up to the top of the silo and dumps it in. So let me show you this. I'm going to do a lot of drawing this 9 weeks, too. I'm not the best drawer either, but my silo, bro, is cylindrical shaped. It's my silo, bro. My silo, that's my little belt going to the top. Boom. They said the angle formed by the ground to the top of the silo is 45 degrees. It said from the bottom, the grain elevator needed to be about, it's 50 feet from the base, so 50 feet here. And they say it's 50 feet tall, the silo itself. Right angle right there. Let me zoom in. And obviously this will have to be 45 degrees up here. Obviously they're just trying to set up a 45-90 scenario for you. If your behind can draw it out correctly, if you can read it and draw it out correctly, it'll be easy to solve. Because all they want to know is the length of the belt. This is a 45-90 triangle. My belt is X. They gave me my silo is 50. The brown from the belt is 50. Or the base of the silo from the belt is 50. What's the length of the belt itself? Single trick question. Go. Thank you, sir. 50 square root 2. But you got to be able to draw it out to be able to answer it. I'm going to do a lot of drawing this now. Sliding on 30, 60, 90. I'm back. Alright. 30, 60, 90 special right triangle. This one a little bit different because all your degrees are different. Let's start there first. This is a right triangle. So classified by its angles is a right. Classified it by its size. What kind of triangle is this? Scalene, thank you. Scalene meaning all the sides are different lengths. But there's still a relationship between the sides on these triangles too. Same way there was a relationship between the sides on the 45-90. It's just that it's three different sides though, so the two legs are not the same on this one. You can even look over to the side. They call one leg the shorter leg, the other leg the longer leg. Alright, on this one, the shorter leg is always opposite the 30-degree angle. The longer leg is always opposite the 60-degree angle. Y'all should remember this anyway from when we did that unit when we were, you remember we tried to figure out, okay, which side was the shortest, middle side, and the longest side. Across from those, the shortest side is always across from the smallest angle. That type stuff. So y'all should still remember all that. And I mean, honestly, it's visual. You can see which side is the shortest side. You shouldn't be confused about that anyway. So, you got shorter leg, longer leg, and then you got your hypotenuse. I always add a rule in on this one. It's three. They give you 3 lines here, but it's really a 4th line we need. Because the shorter leg is kind of like the center of this whole situation. Everything you do has to go through the shorter leg. So in that case, I got to give you 2 different ways to solve for the shorter leg. So we need to add another one in up here. Add another one in. We're going to highlight our shorter leg. I might make that green. So if I'm looking for the shorter leg, I'm doing either one of these 2 things I'm about to tell you now. So the first one I'm going to do coming from the hypotenuse. Say if they gave me the value of my hypotenuse. Say, I'm going to just throw a number out there. Say the hypotenuse was 10. Say they told me the hypotenuse was 10. To find my shorter leg, I will take the hypotenuse, and I'm writing it here, the hypotenuse, whatever it is, I'm going to divide it by 2. That is going to give me what my shorter leg is. So in this case, if say my hypotenuse was 10, I'm just writing a number up here. That means my shorter leg would have to be 5. Now, coming from the other direction, they could ask you for the shorter leg, and the only thing they give you is the longer leg. If that's the case, if I'm looking for the shorter leg and they give me longer leg, I'm using this one. The one that's going to be longer leg divided by square root of 3. So I'm going to put a number out here on my longer leg to make it work. My longer leg would have to be this then, 5 square root 3. And then if I would divide square root of 3 off of this, then I would get the 5 for my shorter leg. It would just cancel off. Like I said, the shorter leg is kind of like a little central area. So you have to go through it and get whatever you need. Even for the other two. So next one, longer leg. If I'm looking for my longer leg here, I would need the shorter leg, and it's going to be the shorter leg times square root of 3. And then the last one is the hypotenuse. If I was looking for the hypotenuse, if I didn't know what that was, I would have to have my shorter leg, and I would do my shorter leg, whatever number I have for that, times 2. The main thing some kids get mixed up on with this, and I think Juan is going to be one of those, is when you're reading this. When you're reading, whatever you're looking for is what the first word you should read. So say if I'm trying to find my shorter leg, I'm reading one of these two, and I'm going to figure out real quickly because I'll know what I have. Like, say if I'm looking for my shorter leg and they gave me longer leg, then I need to be reading this one right here. If I'm looking for the shorter leg and they gave me a hypotenuse, I need to be reading this one right here. Say if I'm looking for my hypotenuse, I just need to read this right here. If I'm looking for my longer leg, I need to be reading this one right here. Whatever you're looking for is the first word you should be reading. Alright. Ain't nothing to it but to do it. Faith, start us out. You do number 5. Faith, on number 5, let me start you out. I'll tell you what they gave me. On number 5, this is a 30, 60, 90 triangle. They gave me my hypotenuse, Faith. I need to find my short leg, and then I need to find my long leg. Now, Faith, on this, and that's why I say everything happens through the short leg, because on this, you can't go from hypotenuse directly to short leg. I mean, directly to the long leg. You got to go from your hypotenuse to the short leg, then you can find your long leg. You have to go around this way. Everything kind of happens through the short leg in this triangle. So, I even draw arrows on this one. I draw arrows showing my path. So, they gave me hypotenuse, Faith. I need to find my short leg. How am I going to find my short leg? Thank you. We're going to divide 32 by 2. 32 divided by 2. And what did you get from that, Faith? I know you're not doing that in the calculator. 16. Then after that, Faith, we need our long leg. Thank you. 16 times square root of 3. We're going to multiply by square root of 3. That'll take us to our long leg, which is 16 square root 3. Like I say, this is one of the cleaner ones, of course, but at some point you already know it's going to get dirty like it did on the front. We're going to have to rationalize. So x is 16, y was 16 square root 3. Sliding over, that one's simple. We can move past that. I think it'll be okay. Number 6, who can I follow with this? Jamal. Number 6. They give us the long leg, bro. They want us to find the short leg and the hypotenuse. Got to do short leg first. We can't go directly from long leg to hypotenuse. Got to get the short leg. Okay, so here we're dividing, you say, by square root 3. Hold on. You can't just do that. When you do that, what you get for y? You should see that as a problem, man. You said 20 divided by square root 3. That's what you're going to write down as your answer? No, you can't do that. We talked about this on the front. You can't leave a radical sign on the bottom of your fraction. So what are you going to do to get that off the bottom? Good. You're going to multiply by square root of 3 over square root of 3. That's multiplying by 1. So we're going to get that off the bottom. We'll clean it up. Here you're going to get 20 square root 3 over square root of 9. And then we can simplify that. Square root of 9 is 3. So 20 square root 3 over 3. And then the last thing you need to look at is if you could do the fraction here. It's 20 divided by 3. You can't. But I'm telling you, there will be some ones y'all can do. When you get to your practice, there's going to be some ones you can simplify even more. Like, you may see one time where it'd be like 21 divided by 3. If it's 21 divided by 3, you can do that. And you can just make it 7 square root 3. Make sure you simplify it all the way down to its base. So the y is 20 square root 3 over 3. What was your question, Dio?
I thought it was just like this one. We did the double square root.
Yeah, it is.
We just took square root of it.
It is.
I'm talking about after we did that. After we did this part here.
Yeah, 3 times 3 is square root of 9. Square root of 9. 3. Alright. Then from there, now we're going to the the hypotenuse. So you're doing what? Multiply by 2. So on this one, we're multiplying 20 square root 3 over 3 times 2. I don't want you to overcomplicate this one. You can make that 2 or 2 over 1, and then you can multiply straight across. Yes. Excellent, sir. Like he just said, it'll be 40 square root 3 over 3. And you can't simplify that anymore because 40 divided by 3 will not give you a whole number. So 40 square root 3 over 3 would be my x. Sliding over. Number 7. I'll make this one good. Miss Johnson. Number 7. 30, 60, 90 triangle. They gave us the long leg. We need to find the short leg and then our hypotenuse. So we need to find short leg given the long leg. What should we do first? I know, you go to the restroom. Good. We're going to divide 9 square root of 3 by square root of 3. So I'm just showing you the movement right there, but I could actually do it over here. Doing it over here, I'm going to do it in another color. 9 square root of 3 divided by square root of 3. Y'all should know what's going to happen right there. What's going to happen? They're going to cancel right here, right? Leaving me with just what? Alright. So short leg is 9. And then from there, Miss Johnson, we need to find long leg. I mean hypotenuse. I almost messed up. I did that last class too. We need to find the hypotenuse. Hypotenuse equals what? Johnson. Hypotenuse equals what? Not the actual answer. What it say? Thank you. Just tell me that. So what's the short leg times 2? I be taking too long. Thank you. Alright. So x equals 9, y equals 18. Hopefully the majority of them be as simple like this one, but you're gonna get something like this now. The one on the test might be like this. I can't remember. The one on the test might be like this, which is not hard, but this is what we're trying to get you to be able to understand both of them, be able to do both of them in one problem. So number 8, the let's mix it up problem. Not bad, but you need to know how to do this. This one, you got a 30, 60, 90 triangle and a 45, 45, 90 triangle connected to each other. You need to understand the relationships and how they're going to transfer from triangle to triangle. The top one, 30, 60, 90. The bottom is the 45, 45, 90. So while you're at this, and the only thing they gave me was the hypotenuse of the 30, 60, 90 triangle. So I'm going to work my way into that one first. So the set of rules I need to be looking at first is the 30, 60, 90 rule. And then once I get into that 45, 45, 90 triangle, then I need to be thinking about the 45, 45, 90 stuff. So we're going 30, 60, 90 first. You know what? This is a 1 problem. 1. So they give me the hypotenuse on the 30, 60, 90 one, bro. X is on my short leg of the 30, 60, 90 triangle. So I want to find my short leg one, and they gave me my hypotenuse. What should I do? Divide by 2. This is a good start one. What's the value of X? 6. And then after that, now granted, I don't need my long leg, but I kind of do need my long leg. Let me ask you this question, and somebody's going to see this. The long leg on the 30, 60, 90 triangle is the same as what on the 45, 45, 90? No, what? No. That's not what I'm asking. I'm not asking for numbers, bro. I just want to make sure y'all see the relationship. Huh? Yes. The long leg on the 30, 60, 90 triangle, which is here, would be congruent to my Y on my 45, 45, 90 triangle. Because those two legs are the same in the 45, 45, 90 triangle. Y'all follow me? Alright, that's what I'm asking. I ain't asking for no values right now. So once I get the long leg on the 30, 60, 90, I'll know it's the same as Y. My leg. It's a regular leg on the 45, 45, 90. Alright, 1, how do we get the long leg given that we have the short leg? Long leg equals okay, so I'm going to multiply short leg times square root of 3. That's going to give us what, 1? 6 square root 3. And that's good for me right there. So 6 square root 3 is my long leg. So what's the value of Y1? 6 square root 3. And then the last thing, 1. Now 1, I'm in my 45, 45, 90 triangle. I need to know Z, which is my hypotenuse. So to get the hypotenuse on the 45, 45, 90, what are you going to do, 1? Multiply by what? Say it again? No. Look at this. You looking at the 45, 45, 90 stuff? See, I told you how to switch your brain over. Go ahead, Monty. What? Say what you said again. I don't know if you said it right. Okay. Yes, okay, you did say it right. Okay. I thought you just said 2. Yeah, we're multiplying by 6, square root of 2. And so it's going to be, I guess I can write it out. So it'll look like this: 6 square root of 3 times square root of 2. Like Imani said, if you do that, it's going to give you 6 square root 6. So my z is 6 square root 6. So x was 6, y was 6 square root 3, z was 6 square root 6. If you're not done, I'll do it for you. Alright, this is number 8 on practice and home learning. So on this one, you got two triangles connected, but they're both 30, 60, 90 triangles. Some of y'all having a little bit of issue with this. So it's 30, 60, 90 here, and you got a 30, 60, 90 right here. All they gave me was the short leg on the smaller 30, 60, 90 triangle. So I need to find stuff on both those. So I'm going to work my way around the shorter one first. On the shorter triangle, going this direction, my hypotenuse would be 2 times my short leg. So whatever my short leg was times 2, which would be 14 square root 3. That's easy. Going the other way, this way you might have a little bit more of a challenge. You need to find this longer leg on this one. Shooting this way. The longer leg is equal to what's that? Times square root of 3, right? Alright. So we got times by square root 3. I'm going to do the work for it up here. So it's going to be 7 square root 3 times square root of 3. When you get that, you're going to get 7 square root 9. You cannot leave that like that. It seems a lot of people today leaving it like that in the first period and this period. You can take the square root of 9. If you can take something, do it. I can take square root of 9. Square root of 9 is what? 3. So I'm really doing 7 times 3, right? 7 times 3 is 21. So my long leg on this one will be 21. So my long leg is 21. My long leg on my small 30, 60, 90 triangle is the same as the short leg on the bigger 30, 60, 90 triangle. Y'all follow what I just said? I don't think I said too much. This long leg on this small one is the same thing as the short leg on my big one here. So if that's the case, I'm treating this as my short leg now, and I'm working my way into the big triangle. In the big triangle, I got the short leg. I need to find the hypotenuse. Hypotenuse is 2 times the short leg. So 2 times 21. 42. My y equals 42. Then I'm going the other way. I'm finding my long leg here. Long leg is short leg times square root of 3. So 21 square root 3. Yeah, that can't be that hard. So x was 14 square root 3. Y was 42. Z was 21 square root 3. Try those word problems.